are on number 24 on the online homework, and the first thing we want to integrate, cosine cubed 9 theta d theta. And there, I mean, you can, and I just did this myself, you can get yourself really like you're not sure what to do, but there is a strategy for these, and I personally, and by the end of the chapter, I will have kind of given you all of the little strategies, but on this one, it's often best to split it up. So you can think of this as cosine 9 theta times 1 minus, times cosine squared 9 theta d theta. And so then this is the integral of cosine 9 theta times cosine squared 9 theta is 1 minus sine squared 9 theta by the Pythagorean identity, right? Okay, and then the trick here is if you let u equal the sine of 9 theta, then du is going to equal the cosine of 9 theta d theta, right? Which is exactly what you have right there. Oh, it's going to be 9 times that, right? Because you have a chain rule. And then, so you can write this as 1/9 du is equal to cosine 9 theta d theta. So you'll have a 1/9 in front, and then you'll have 1 minus, well, just u squared, and then du. See how cool that is? That was really clever. You following? All right, and so then this will be 1/9, and this will be u minus u cubed over 3. And so that will be 1/9 the sine of 9 theta minus sine cubed 9 theta over 3 plus c. And so that, if you come to the computer, if it's multiple choice, and it looks like it is choice D on the computer. Good job. Wow, I got one right. Okay, now we want to do the cosine of 5, or cosine, now we want to integrate cosine to the 5th 9 theta d theta. And it turns out that it's a similar sort of strategy that you want to use on this one. You want to think of it as the integral of cosine to the 4th 9 theta d theta, the integral of cosine to the 4th 9 theta times cosine 9 theta d theta. So it's a similar strategy, okay? And then you're going to think of this cosine to the 4th 9 theta. You can think of that as if you had they have an error in their solution. If you have sine squared theta plus cosine squared theta equals 1, then you know that cosine squared theta is equal to 1 minus sine squared theta, right? That's your Pythagorean identity. So you can think of cosine to the 4th 9 theta as cosine squared 9 theta squared. times cosine 9 theta d theta. And so you'll be able to then replace cosine squared 9 theta with 1 minus sine squared 9 theta. So this is going to be 1 minus sine squared 9 theta squared times the cosine of 9 theta d theta. And you really have to resist the urge to multiply this out. Oh, you're not going to. The actual problem was theta over 4, not 9 theta. But I'm going to do this one, and then I'll fix the final. Okay? I copied the problem wrong. I was thinking it was just the same problem, but with a fifth, but it's actually a little bit different. All right, so this is the antiderivative of 1 minus sine squared 9 theta squared cosine 9 theta d theta. All right, so if we let u equal the sine of 9 theta, then du is going to equal 9 cosine 9 theta d theta. So if we have a 1/9 here, and then we'll have the integral, and this will be 1 minus u squared squared, and then du. You with me?
Your conference is scheduled to end in 2 minutes.
And then you'll have 1/9, and you can FOIL this out. This is 1 minus 2u squared plus u to the 4th du. And then this is 1/9, and then this is u minus 2u cubed over 3 plus u to the 5th over 5. And so then this will be 1/9, and then it's sine 9 theta minus 2 sine cubed 9 theta divided by 3 plus the sine to the 5th of 9 theta divided by 5 plus c. Does that make sense? All right, and so now on this problem online, it was actually the antiderivative of the cosine to the 5th of theta over 4. It wasn't 9 theta. So what's going to happen is you're going to have just a 4 in front, right? And then you'll have theta over 4s everywhere. So is that okay? I screwed up. So it should be, so the answer is 4, and then sine theta over 4 minus 2 sine cubed theta over 4 over 3 plus
Your conference is now over. Goodbye.
5th theta over 4 over 5 plus c. That's what it is for the one online. Which is choice C. Fantastic. So what they're trying to get you to see, or I don't know if they're really trying that hard, because I don't know. Let's assume they care. If you go back and look at the first one, its answer was 1/9 sine 9 theta minus sine cubed theta 9 theta, whereas this one, notice it was 1/9 sine 9 theta and then 2/3, and then it was over 5. You know, it could be, and it does turn out, that there's actually like a pattern, like if you then had to do cosine to the 7th 9 theta, you would have a similar pattern. So if you had to integrate cosine to the 7th 9 theta d theta, right, then you would do the same thing. You would think of this as cosine 9 theta times cosine to the 6th 9 theta d theta. right? And so then this would be cosine 9 theta, and then this would be 1 minus, okay, think of this as cosine to this, gosh, this is why they had chalk. Okay, so this will be cosine 9 theta, and then, see that on my tablet I can erase. Have you noticed that? And it's just this little change has made a difference to me. Think of this as cosine squared 9 theta cubed d theta, right? And then cosine squared can be written as 1 minus sine squared theta cubed d theta. You see what I'm saying? And so you do, there should be a 9 here. And then you do you still do your u substitution where u is sine 9 theta. And so you'll get this part out, but then you'll have 1 minus u squared cubed, which you'll have to FOIL out and then get it. You'll do 1 minus u squared times 1 minus u squared times 1 minus u squared and figure it out. But the pattern will be actually, it turns out that there's something called Pascal's triangle, which helps you FOIL out. It helps you to do, if you wanted to do a plus b squared and a plus b cubed and a plus b to the 4th. If you did that, there's actually a pattern there that occurs, and so you could use that pattern to kind of figure out what the integral is going to be. And I guess that's what they're trying to say. So since I have all the time in the world, I guess I do. You don't have to take your test till. I want to show you something. If you look, I shouldn't have. If you look on your computer, I lost it. Let me go back to it. You go back into the textbook. If you look at the entire textbook, there are actually a brief table of integrals, and you can find these table of integrals everywhere, but that particular one is normally, see, cosine to the n, and they kind of show you the pattern of what it's gonna, how you're gonna do it. So you start to kind of get into a little pattern of what that's going to look like, and you can just integrate down. And some will actually even break it down more, like when it's odd and when it's even, depending on the textbook, because you do a little bit different technique when it's odd or when it's even. But this is what they used to do, because that was a lot of work to get that integral. And so what you'll learn at the end of this chapter is in chapter 8. In the next unit, we'll finish this chapter, and in section 8.6, we'll look at integral tables and computing algebra systems, because we'll learn that, okay, these are fun to do, but it's exhausting. And so since there's all these patterns, learning how to use the tables or a computer that helps you do it is much more efficient. But it's kind of funny because, at the time, there were people that their dissertations and their doctoral work was coming up and making and creating these tables and that sort of thing, and coming up with these little patterns. It seems like it would be, now the doctoral work is so much, I don't know, you have to create something. So we should be proud of what they created, but now once it's created, it's hard to think it's as cool. You know what I mean? Like when it first gets created, it's really great, but now you're like, well, I could have done that. But no, you didn't. You have to come up with something new. I don't know.